What is it about space? Why are we so fascinated by the sky, by the stars, and the moon, and the planets? What is it that draws us to look up? We are creatures of light, and some of you might think that I'm misquoting Yoda. Yoda said, "We are luminous beings, not this crude matter." And I agree with him. But that's not what I meant. We define so much of our reality by what we see. Our eyes are such a powerful sense. Our sight is such a part of our definition of what is real and what is not real, that sometimes we're even fooled by it, by the appearance of just what our eyes tell us and not what our imagination can show us as well. And sometimes it takes a visionary to take us to the next level of truth. In the 1500s, a monk named Giordano Bruno, he did that for us. He took the Copernican idea that the Earth wasn't the center, but rather the Sun was the center of our system, and the Earth orbited the Sun. And he extrapolated that to the whole universe. And he said, what if each one of those stars in the sky was a sun with planets? And it wasn't for almost 400 years until we discovered the first planet around another star. Dr. Alex Wolszajn, a professor of astronomy here at Penn State, in 1992 discovered the first planet around another star. And since then, the number has grown to thousands. There's one spacecraft, Kepler Space Telescope, that has discovered over 2,600 candidate planets, and it's only been flying for a couple of years. If you go out into the night in the summer and you look up at the sky, you'll see a constellation called Cygnus, the Swan. It's a nice big constellation, very bright stars. It's a cross. Imagine a bird spreading its wings with a long neck leading the way. And you put your hand up over Cygnus, and in a corner of Cygnus, you cover the one patch of the sky that Kepler's looking at. And that's where those 2,606 candidate planets can be found. And there's other techniques that they're using, not just this one telescope, but there's other telescopes that are finding planets around other stars. And this idea that we're not unique as a system is part of what science is all about, where we explore something here, we understand that it's true, and then we say, well, the laws of physics are thus, what we see out in the sky must not be that different from here, otherwise it would be violating the laws of physics. In the last century, astronomers looking out into the sky, understanding how stars were born, how they formed, how they lived, and how they died, were doing work that was paralleled by work that was being done in laboratories, where physicists were smashing together atoms and learning about the release of energy and the absorption of energy and the creation of new atoms from old atoms, where hydrogen and hydrogen would combine together to make helium, and through more and more energetic reactions they could make heavier and heavier elements. And all of a sudden they looked at each other, the physicists and the astronomers, and they said, wait a minute, this is all the same thing. And they realized that what was going on in stars goes on in the laboratory, and this idea of astrophysics came to be. Not astronomy, not physics, but astrophysics. And that what's going on in our laboratories isn't special, it's not different from what happens in the stars. And this idea came to a point where they realized that every atom in your body, the hydrogen that makes up part of the hydrogen and the oxygen that makes up the water, the calcium that makes up your bones, the carbon, which is the chain that makes up your DNA. We're all formed in the crucible of these stars, early universe stars that lived and died fast and created these heavier elements from the basic material of hydrogen and the energy of gravity, squishing everything together. Every single atom in your body started out in the heart of a star. And more recently, we've looked up into the sky and we've seen not just atoms and maybe some simple molecules, but larger chains. Chains that hook all together and they they look out into the night sky with telescopes, and they look up into nebular clouds, places where stars are being born. The clouds are formed from material that came from older stars that died, and then the dust recollected to form new stars. And in these nebular clouds, they're seeing large enough molecules, they're identifying these molecules, and those molecules are amino acids out in space. And your DNA is made up of amino acids all linked together. Your entire being is programmed from the moment of conception to run on what amino acids in a certain order are telling your body to do. And they see amino acids out in space. They've created this new field called astrobiology to deal with this reality. And they've said, space tells us everything. It's everything. Why are we so fascinated with space? There's a lot to be fascinated by. This is a picture of Mercury. This picture was taken in 2008. I love this picture. I helped to take this picture with about 400 other researchers, scientists, engineers, technicians. The Messenger spacecraft flew past Mercury in 2008, and as a spacecraft systems engineer, I got to be right there in the control room when this picture came down. Fascinating. Nobody had ever seen this side of Mercury before. One of our closest neighbors in the solar system. It's really, really hard to observe, really hard to see because it's so close to the sun. NASA had built a spacecraft, flew past it in the mid-70s, and only imaged one side of the planet. Mariner was a wonderful craft, but we didn't see the other side, and now Mercury still has its only artificial satellite. Messenger is there, in orbit around the planet right now, it's got a full map of the globe now. And the discoveries that have come from this are fascinating too. Right? On the North Pole of Mercury, where the sun never shines into the deeper craters, we have just discovered water ice in these craters. This hottest of planets, smack up right next to the sun, where softer metals like lead would melt on the surface in the day side of Mercury, there's actually frozen water ice. Fascinating. What does this mean? It means that what we think we know about the universe yesterday isn't what we're going to find out tomorrow. Who would have suspected that there would be water ice on this hottest of planets? And yet there is. And when we look out into the night sky now, and we look up into Cygnus and we see that spot where there are thousands of planets, and remember, that's just one tiny spot. It's a pretty dense spot, but it's only tiny. If you extrapolate that out to the whole sky, how many billions of planets are there in our galaxy? And there are physicists who are calculating that, and the number is billions. But if what we thought about Mercury was wrong, and it's that close, imagine the possibilities of what we will discover in these planets around other stars that we're finding. This could be the most exciting time to be alive. I expect that in our lifetime, that the exoplanet researchers, as they're called, exoplanet, I love this word, right? That the exoplanet researchers are going to look at some of these planets with bigger and better telescopes, and they're going to glean from the light coming from those planets. They're going to see green, and they're going to say that is the signature of chlorophyll, because when we look at chlorophyll through a spectrograph here and look at its light and say this is what chlorophyll looks like, it looks exactly like this. And the laws of physics tell us that if it happens here and we see it there, then it must be. And they're going to look up and they're going to say there's something growing